Hello students. In the last video we introduced you to some of the terms that we use when we're studying quadratic relationships or quadratic functions. The only one we've actually looked at in some detail is a very simple quadratic function, y equals x squared. So what we're going to look at now is effectively all quadratic functions. So far we've only looked at simple examples of quadratic functions. Here's the rule for any quadratic function. And when we say any quadratic function, what we normally call that is the general quadratic function. In other words, every quadratic function will fit that rule. So what do all these letters mean? Well, x and y are just the coordinates of the points on the graph. A is what you multiply x squared by. So you can multiply x squared by any number except 0. Whoops, let me get my pen tool. You can multiply a by any number except 0. The reason for that is if a is equal to 0, 0 times whatever x squared is 0, and you lose your x squared term. And we have to have an x squared term if it's to be a quadratic function. Now we can also add on to that some number times x. And this number b can be any number whatsoever, including 0. And then finally, we can also just add on what's called the constant term, which is just a number by itself. And again, that number can be anything, including 0. So a, b, and c are the numbers that define a particular quadratic equation. So for example, let's have a look at this quadratic equation down here. So y equals ax squared. So in this case, a is equal to 3. Plus bx, so b is equal to 5, and minus 7, so c is equal to negative 7, because that's effectively the same as plus negative 7. With this quadratic equation, I've written it slightly differently. Notice the x squared term is second, but still the a is the number that's on the x squared term. So it's not the first number that you see, it's the coefficient on x squared. So in this case, a is equal to negative 2/3. Notice I don't have an x term, so I'm missing that term. That means b must be 0 in this case. And then finally, the constant term, the number by itself, is square root of 5. So what this teaches you is the order of the terms is not important for identifying a, b, and c. And a, b, and c can be fractions, and they can be square roots. Okay, have a look at this equation down here. This one, it looks a little bit like a quadratic, but in fact it's not a quadratic. So have a look at it and tell me why you think it's not a quadratic. And if you go up to this rule just here, a is any non-zero number. In this case, a is equal to 0. If a is equal to 0, that just goes to 0, and the equation is just 5x takes 7, which turns out to be a linear equation and not a quadratic equation. This equation here, again, at first glance looks like a quadratic, but the power on x is a 3 and not a 2. So a quadratic equation, the biggest power of x has to be x to the power of 2. Okay, what we're going to do here is decide if each of these functions up here, each of these relationships, is a quadratic or not a quadratic. Okay, this one is pretty easy to start with. So 6 plus 3x plus 0x squared. Well, again, the order doesn't matter, but the problem here is the coefficient on x squared is 0. That means it's not a quadratic function. That has to be any number except for 0. What do you think about g equals 10 take h squared? Well, you might think it's not a quadratic because it's not x and y, but the letters don't matter. I could have the h-axis and the g-axis. So the letters are unimportant. So it's still a quadratic because of that. In this case, a, the coefficient in front of the squared term, is negative 1, so that's okay. The constant term is 10. In this case, b must be 0 because they don't have a h term. So that one is a quadratic. What about this guy up here? Let's drag it so we can have a good look at it. Well, there's the x squared term. That's not equal to 0, so that's fine. there's the x term. So the value of b is negative square root of 2, and pi is a number, so that's the value of c. So that is a quadratic, even though it looks a bit more complicated than some of the others. A is equal to 2/3, b is equal to negative root 2, c is equal to pi. What about this guy just here? Well, the numerator is a quadratic, but once I divide all of those by 2x, I no longer have a quadratic. So because of that denominator of 2x, that one's not a quadratic. That one here, well, again, the coefficient on x squared is 5, so a is 5, b is 3, and there's no constant term. There's no number by itself. That's okay, so c is 0. That qualifies as a quadratic. This equation here, or this function here, has got an x cubed term, so that's not. And this one looks a little bit tricky because we've got like a fraction, but you could write x squared over 2 as 1/2 x squared. So you can actually write that with a coefficient of 1/2. So that's okay. B is equal to 3, C is equal to 0 because we don't have a constant term. So that one is a quadratic function. So make sure you understand why these are all quadratics and why none of these is a quadratic. Okay, in the next video, we'll start to look at graphing some more interesting quadratic functions rather than just y equals x squared.